In a hall at the Washington Navy Yard, there is a machine that looks like a small submarine bolted to the underside of a float the size of a railway carriage. It is white. It is dry. Children walk past it without stopping. 2 men were once sealed inside the steel ball at its base, lowered almost 7 miles into the Pacific Ocean, and at 30,000 feet, something in it broke. The float was full of gasoline, tens of thousands of liters of it, because gasoline floats, and unlike air, it barely compresses under pressure. That was the whole idea. The Trieste could not steer and could not swim. It sank. To come back up, it dropped 9 tons of iron pellets, held in place by electromagnets, so that if the power died, the ballast released itself and the ship rose on its own. On the morning of the 23rd of January, 1960, Jacques Piccard and Don Walsh climbed in from a ship rolling in heavy swell near Guam. The descent took just under 5 hours. Somewhere past 30,000 feet, a plexiglass window in the entrance tunnel cracked, and the hull shook hard enough that both men felt it through the steel. They discussed it. They kept going. They landed in the Challenger Deep with nearly 8 tons of pressure on every square inch of the sphere. Their gauge read 37,800 feet. It was wrong. The real figure is closer to 35,800. They had 20 minutes, and in that 20 minutes, Piccard looked out of the window and reported a fish.
He described it precisely, which is part of the problem. Flat, like a sole, about a foot long, eyes on the top of its head. It moved slowly away into the dark. That single sentence traveled around the world. Life at the deepest point on Earth, with a backbone and a face. Marine biologists doubted it almost immediately. The Danish zoologist Torben Wolff argued within a year that what Piccard saw was far more likely a sea cucumber, a soft, flat, bottom-crawling animal that, in a headlight beam, in a rising cloud of silt, would look very much like a flounder. Walsh, who did not see the animal himself, said later that visibility down there was like looking into a bowl of milk, and that neither of them was a trained biologist. In 2012, the claim was examined properly in a paper in the Biological Bulletin and dismissed. Not because anyone thought the 2 men were lying, because of something in the chemistry of vertebrates that nobody in 1960 knew about. There is a hard ceiling. The Challenger Deep is a long way beneath it.
So, the deepest dive in human history returned almost no science. It was not designed to. The Trieste belonged to the United States Navy, and the Navy had not bought it to look at animals. Watch what it was used for afterwards. In 1963, the submarine Thresher was lost with 129 men off New England, and Trieste went down 8,000 feet to photograph the wreckage on the seabed. In 1966, an American bomber collided with a tanker over Spain and dropped a hydrogen bomb into the Mediterranean. The submersible Alvin located it about half a mile down, and a remote vehicle brought it up. In 1974, the CIA built a 600-foot ship, told the world it was mining metal nodules for Howard Hughes, and used it to try to raise a sunken Soviet submarine from 16,500 feet. That is the honest answer to why we stopped. We never really started. The deep ocean was a military corridor that scientists were occasionally allowed to borrow. The American federal budget for ocean exploration today runs around $46 million a year. NASA's is roughly $27 billion. And then, occasionally, someone did borrow it, and the borrowing rewrote biology. February 1977, the submersible Alvin, on the Galapagos Rift, about 1.5 miles down, carrying a science party of geologists. They were looking for hot water leaking out of the seafloor, testing a prediction about how the Earth sheds its heat. They found the hot water. They also found clams the size of dinner plates, pale crabs, and tubes standing upright out of the bare rock in clusters, some of them taller than a man, with blood-red plumes at the top. There was no biologist in the science party. The ship carried no proper preservative for specimens, so the first ones went into vodka from the galley. Everything written about deep-sea life until that afternoon had assumed it survived on scraps drifting down from the sunlit surface. These animals were not eating scraps. The giant tube worms have no mouth and no gut at all. They farm bacteria inside their own bodies, and those bacteria feed on hydrogen sulphide, the rotten egg gas venting from the rock. An entire ecosystem running on chemistry instead of sunlight. Nobody had predicted it. Here is the ceiling that killed the flatfish. Deep-water fish protect their proteins from being crushed using a chemical called trimethylamine N-oxide. The deeper the fish lives, the more of it the fish carries. But it is a dissolved salt, and at a certain concentration, the animal's tissues become saltier than the seawater around them, and water starts flooding inward. Work the arithmetic through, and vertebrates stop being physically possible somewhere around 8,200 meters, roughly 5 miles. In August 2022, a baited camera dropped into the Izu Ogasawara Trench off Japan filmed a young snailfish at 8,336 meters. It is the deepest fish ever recorded, and it was a juvenile, barely 5 centimeters long. It sat almost exactly on the predicted line. The floor of the Challenger Deep is more than 2 kilometers below that line. Nothing with a spine lives down there. What lives there are amphipods, pale scavenging crustaceans, some of them as long as your hand. One Mariana species appears to coat itself in a film of aluminum, drawn out of the sediment it swallows. Which brings us to what is inside those amphipods. In 2017, a team led by Alan Jamieson tested amphipods collected from the Mariana and the Kermadec trenches, 2 trenches 7,000 kilometers apart, both more than 10 kilometers deep, about as far from a factory as it is possible to get on this planet. Their fatty tissue was loaded with polychlorinated biphenyls, PCBs, industrial insulating fluid, banned across most of the world since the 1970s and 80s. The highest readings from the Mariana Trench came out around 50 times the levels measured in crabs from the Liahe, one of the most heavily polluted river systems in China. And in 2018, when Japanese researchers opened up 3 decades of archived deep-sea dive footage to the public, someone went through it looking specifically for rubbish. The deepest item in the entire catalog was a plastic bag lying on the floor of the Mariana Trench at 10,898 meters. A robot had filmed it in May 1998. It had been sitting in the archive, unremarked, for 20 years before anyone noticed what it meant. There is a fair objection to all of this, and it is the strongest argument against the premise of this whole story. We did not stop. 52 years after Piccard and Walsh, in 2012, James Cameron went down alone in a vertical submersible he had helped design. In 2019, the investor Victor Vescovo went repeatedly and then began carrying passengers. By the middle of 2022, the number of people who had reached the Challenger Deep stood somewhere around 27. More than 680 people have been to space, so the gap is real, but it is closing from the bottom rather than the top. The mapping is better than the slogan suggests, too. You have heard that we have better maps of Mars than of our own seafloor. That is half true. The entire seafloor is mapped roughly, inferred from satellites measuring tiny bulges in the shape of the sea surface. What is missing is detail. As of June 2025, about 27% of the ocean floor had been surveyed at modern resolution, up from 6% in 2017. The question is, who is paying for the rest?
A great deal of that new mapping is funded by an industry that wants to dredge metal nodules off the abyssal plain in places where nobody has finished counting what lives there. We spent 60 years not looking. We may end up doing the survey and the mining in the same decade. There is far more down there, and we will keep going down.